Good day everyone. Planes part 2. In this video, you are going to learn few more concepts and how to find the equation of planes. First, before going into the equation, let me tell you few basic facts. When two planes are parallel, right, their normals will also be parallel. This is a very simple thing which you can remember. If you consider any two planes, right? Now this is a plane and this is a plane. If they are parallel, their normals will also be parallel. If two planes are perpendicular, their normals will also be perpendicular. Okay? Then, if you consider a plane and a line, see, supposing this is a plane and this is a line. If a plane is perpendicular to the line, what will happen? The line becomes a normal to the plane, right? If a plane is parallel to a line, the normal to the plane will be perpendicular to the line. Because you have already learnt in lines, when two lines are perpendicular, the sum of the product of the direction ratios is equal to 0. That is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. That is a very important point which we will be using in the sums. Okay. So now let us move on to the equations. Okay. Now you are going to learn a new formula, that is the vector equation of a plane passing through a point whose position vector, PV means position vector, is a vector and normal vector is n vector is. So what are the two things given to you? One is a point in the plane, that is the position vector of the point through which the plane passes, that is a vector. And you know what is a normal, isn't it? Normal is any line perpendicular. So the normal vector is n vector. Then the vector equation is or vector dot n vector is equal to a vector dot n vector. Okay. Now let us go to the corresponding Cartesian equation. Here the Cartesian equation of a plane passing through a point x1, y1, z1 and the direction ratios of the normal are a, b, c is. There the point is a vector, the normal vector is n vector. Here point is x1, y1, z1 and the direction ratios of the normal are a, b, c. Now it is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is a very important formula because we will be using this in some models whenever we want to find the equation of the plane. If they have given us 1 point or 2 points like that, we will only use this one. Okay. So now you can note down these two formulae in your notebook. Whenever you read any formula, understand what each letter stands for. Just don't mug up just the formula. You should know what is x1, y1, z1, what is a, b, c, like that. Okay. So now these two formulae you are learning now. Let us see few sums based on this. Okay. Model 1. What is model 1? To find the equation of a plane passing through a point and perpendicular to two planes or parallel to two lines. This I give as model 1, that is the plane passes through one point, they will give you the point. Then they will give you two planes which are perpendicular or they will give you two lines which are parallel. Anyway, the concept is the same. Okay. Now, let us see example sum number 1. Find the equation of the plane passing through 1, minus 3, minus 2 and perpendicular to the planes x plus 2y plus 2z is equal to 5 and 3x plus 3y plus 2z is equal to 8. Okay. Now, whenever one point is given and you want to find the equation of the plane, you assume always let the equation of the required plane be a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. That is what we will start the sum with. So, let the equation of the plane B, this is what we are going to find out, okay? Plane B, A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Now, you know it passes through this point. So, that is nothing but x1, y1, z1. Okay. So, it passes through, that is your plane, passes through the point. Which point? 1, minus 3, minus 2. So, you have to substitute it in the place of x1, y1 and z1. So, what will I get now? A into x minus 1 plus b into y plus 3 plus c into z plus 2 is equal to 0. Mark this as equation 1. This is what you are going to find out. That is, after substituting the point, you will get one equation that you are marking it as 1. Now there are two unknowns, A, B and C. Okay, three unknowns are there. Now we are going to solve for them now, right? Using the facts, that is, these two planes are perpendicular. So let me write x plus 2y plus 2z is equal to 5. This is plane 2, and 3x plus 3y plus 2z is equal to 8. This is plane 3, right? Plane 1 is what we are going to find out. Plane 2 and plane 3 they have given. They are perpendicular to plane 1, right? Now, I will write plane 1 and 2 are perpendicular, isn't it? They have given. When two planes are perpendicular, you know that normals are also perpendicular. I have told you that fact, isn't it? So now, therefore, their normals are perpendicular. If the normals are perpendicular, you know the sum of the product of their direction ratios is equal to 0. So, the sum of the product of the DRs, that is direction ratios, is equal to 0. This is the concept we are going to use. So now, if you consider plane 1, what are the DRs? A, B, C. So let us write DRs of the normal to plane 1, okay, is equal to A, B, C. I have already told you, remember, a plane will not have DRs, only a line, that is the normal, will have DRs. So now, DRs of the normal to plane 2. What is that in plane 2? 1, 2, 2. That is the coefficient of x, y and z. Okay. So that is 1, 2, 2. Therefore, we will get 1 into A is A plus 2B plus 2C is equal to 0. Mark this as equation 4. Similarly, you know, plane 1 and plane 3 are perpendicular, isn't it? So, planes 1 and 3 are perpendicular. Therefore, their normals are perpendicular. Their normals are perpendicular. So, let us use the same fact. Okay. So, now here, DRs of the normal to plane 1, A, B, C we know. What are DRs of the normal to plane 3? 3, 3, 2. That alone I will write now. So, DRs of the normal to plane 3, that will be 3, 3, 2. So what will I get now? I will get 3a plus 3b plus 2c is equal to 0. Mark it as equation 5. Let me explain this quickly once. First, you assume the equation of the required plane B. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. They have given one point. You substituted it in the place of x1, y1, z1. You got this equation that you are marking it as 1. They have given you two perpendicular planes. Write them as 2 and 3. Now you know planes 1 and 2 are perpendicular. So their normals are perpendicular. The sum of the product of the drs is equal to 0. You got one equation in ABC. Planes 1 and 3 are perpendicular. Using the same concept, you got another equation in A, B and C. So now 3 unknowns, we have got 2 equations. How to solve them? There is a method called rule of cross multiplication. Using that, we are going to solve for the proportional values of A, B and C. Okay. We have got 2 equations in A, B and C, that is equation 4 and 5, right? Now I told you we are going to solve it by the method rule of cross multiplication. That is, you write A, B, C, again A, then B, right? Then write the coefficients of ABC. 1, 2, 2, 1, 2. Come to the equation 5. 3, 3, 2, 3, 3. Okay. So I have written the coefficients of ABC in equation 4 and 5. Now I will write A by, don't take A, take these two. Like a determinant you have to write. That is 2 2s are 4 minus 3 2s are 6. You know determinant, there will be a minus in between, right? That one. Then you write B by, leave the B1, come to these two. So 2 3s are 6 minus 2 1s are 2. That is equal to C by, leave the C, come to these two. 3 1s are 3 minus 3 2s are 6. Do you understand? So write A, B, C, A, B. Write the coefficients below them. Then when you write A by, don't take this one, take these two. When you write B by, take these two. When you write C by, take that. Do as a determinant. So now I get A by minus 2 is equal to B by 4 is equal to C by minus 3. Actually, they are all proportional only. I cannot say A is minus 2 or B is 4 like that. So let me equate it to some constant of proportionality K. So I will be getting A is equal to minus 2K, B is equal to 4K and C is equal to minus 3K. Here you can simplify the numbers if they come like that. Okay. So now after getting ABC values in terms of K, now substitute them in equation 1 because that is our required equation. Okay, the plane what we want is equation 1. So now I will get minus 2k into x minus 1 plus 4k into y plus 3 minus 3k into z plus 2 is equal to 0. Now for the 3 terms k is common. Actually I can take the k out and then I can just remove it because I have a 0 there. So I will get minus 2x plus 2, okay, plus 4y plus 12 minus 3z minus 6 is equal to 0. So definitely k will go, right? So the next I will write minus 2x plus 4y minus 3z. This is 14 minus 6. So plus 8 is equal to 0. Generally, we won't write the first term with a minus. It's not wrong if you write, but it is better if you write it as 2x minus 4y plus 3z minus 8 is equal to 0. This is the equation of the required plane which passes through that point and which is perpendicular to the two planes. Suppose they ask you the vector equation. After you get the final result, now it is very easy. You can write it is r vector dot 2i cap minus 4j cap plus 3k cap, that minus 8 you bring here. So this is the vector equation of the required plane. You have learned how to convert in the last video itself, right? So this model, have you understood? Given one point and then giving two perpendicular planes. Even if they give two parallel lines, proceed in the same way, the same thing. You will get two equations in ABC and use this rule and then do it. Okay? Now, let us move on to the next model. Model 2. To find the equation of a plane passing through 2 points and perpendicular to a plane or parallel to a line. So, in this model, the plane passes through 2 points. They will give you 2 points and one perpendicular plane or one parallel line. That is the model 2. Let us see example sum number 2. Find the vector equation of the plane passing through 2, 1, minus 1 and minus 1, 3, 4 and perpendicular to the plane x minus 2y plus 4z is equal to 10. So whether they give the equation in vector form or Cartesian form, the points in vector or Cartesian, you convert them into Cartesian, find the Cartesian equation and then you can convert it into vector. That will be easier because if you learn everything and you will be confused then. So I am teaching you only the Cartesian way. Now, as we assumed in the last sum, let the equation of the plane be, okay, let the equation of the plane be a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Then what did we do? The first point we have to substitute in the place of x1, y1, z1. Okay. So it passes through, actually you can take any one point, right? It passes through 2, 1, minus 1. Therefore what will happen? A into x minus 2 plus b into y minus 1 plus c into z plus 1 is equal to 0. This is the equation 1. Okay. So in the equation 1, you will have 3 unknowns a, b and c. Now there is a second point. We have to make use of it. Now I will write plane 1 also passes through, what is that point? Minus 1, 3, 4. Now I will substitute this point in the place of x, y and z and I will be getting an equation in ABC, right? So now I will write a into minus 1 minus 2 plus b into 3 minus 1 plus c into 4 plus 1 is equal to 0. So I will get minus 3a, then I will get plus 2b, then I will get plus 5c is equal to 0. I will keep this as equation 2. That is an equation in A, B and C. So do you understand the difference between model 1 and model 2? The first point x1, y1, z1. The second point in the place of x, y, z. So you get an ABC here. Now let us write that plane equation. That is x minus 2y plus 4z is equal to 10. I will call it as 3. Now you know planes 1 and 3 are perpendicular. It is given, right? Are perpendicular. Immediately you know their normals are perpendicular. Therefore, their normals are perpendicular. So let us find the drs. drs of normal to plane 1, right? Drs of normal to plane 1, ABC, okay? ABC. The drs of normal to plane 3, plane 3, what is it? That will be 1 comma minus 2 comma 4. 1 comma minus 2 comma 4. Now, they are perpendicular. So, you know the same concept. We have already written that. So, it is A minus 2B plus 4C is equal to 0. We have to mark this as equation 4. So, now 2 and 4 are the two equations. Now we are concerned. Okay. So let me write the 2 also here. That is minus 3a plus 2b plus 5c is equal to 0. Now let me apply the rule of cross multiplication. Whenever you get 3 unknowns and 2 equations, this is the rule you have to apply. So now a, b, c, a, b. First I will write 2. You can write any one. That doesn't matter because only the signs will change. So minus 3, 2, 5, minus 3, 2. Then 1, minus 2, 4, 1 and minus 2. So I will get a by. So 2 4s are 8. Okay. Minus of minus, so that will become plus. That is equal to b by 5. Then plus 12. Then c by, we will get 6 minus 2. Okay. So now that gives me a by 18 is equal to b by 17. That is equal to c by 4, which is equal to k. So now we have to get ABC in terms of k and we have to substitute in our equation 1, isn't it? Okay. So now we will get A is equal to 18k, B is equal to 17k and C is equal to 4k. Now let us substitute it in equation 1. So we will get 18k into x minus 2 plus 17k into y minus 1 plus 4k into z plus 1 is equal to 0. Now I can take the k outside for everything. So I will get 18x minus 36 plus 17y minus 17 plus 4z plus 4, that is equal to 0. Now the k can be cancelled because 0 by anything is 0. K you can take that side. So what will you get now? 18x plus 17y plus 4z. This is 36. This is 17. So you will get minus 53 plus 4. So minus 49 is equal to 0. Now this is the Cartesian equation. Since they have asked the vector equation, let us write it. So the vector equation is or vector dot 18 I cap plus 17 j cap plus 4 k cap, that is equal to 49. This is the vector equation. So are you clear with the two models, that is giving 1 point and 2 perpendicular planes, giving 2 points and 1 perpendicular plane? Okay. Let us do one more model today in this video. Another new formula for you now. Equation of a plane passing through 3 non-collinear points x1, y1, z1, x2, y2, z2 and x3, y3, z3 is. Now this is only the Cartesian, okay? Because this is the easiest, I am teaching you only the Cartesian. It is determinant. Determinant is very easy for us, isn't it? So x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, see everywhere it should be x1 here, y3 minus y1, z3 minus z1 is equal to 0. you have to write is equal to 0, otherwise it is not an equation, remember that. So using this formula, it's a very simple thing. Let us do one sum. If 3 points are given, how to find the equation of a plane, okay? Find the equation of the plane passing through A, 2, 2, minus 1, B, 3, 4, 2 and C, 7, 0, 6. Okay, a very simple model, this one. So here, let us write, let A be 2, 2, minus 1. Write x1, y1, z1. Okay, write B, that is the second point, 3, 4, 2, x2, y2, z2. Cb 7, 0, 6, which is x3, y3, z3. That's all. Now write the formula. Equation of the plane passing through three non-collinear points. Actually, you need not check because they will give like that. Otherwise, you can't find the equation of the plane. Okay. Non-collinear points is, you write the determinant, x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. That's all. We are going to now substitute, right? So now what will we get now? X minus 2, y minus 2, z plus 1, right? Then the second row will be 3 minus 2, that is 1, 4 minus 2, that is 2, 2 minus of minus 1, that is 3. Then 7 minus 2, don't do this one, you have to subtract only x1, remember that. 7 minus 2 is 5, 0 minus 2 is minus 2, 6 minus of minus 1 is 7, is equal to 0. Let us now expand. So I will get, put a bracket here, x minus 2 into, okay. Then you will get 14 plus 6 minus y minus 2 into, leave that, you will get 7 minus 15 plus z plus 1 into minus 2, then minus 10, that is equal to 0, right? So here this is 20, you will get a 20x minus 40. Here this is minus 8, minus into minus will become plus 8 now. So plus 8y and minus 16. Here this is minus 12, so you will get minus 12z minus 12, that is equal to 0. So you will get 20x plus 8y minus 12z. You will get, everything is minus 40, 56, 68 is equal to 0. Everything is divisible by 4. So let us do it. We will get 5x plus 2y minus 3z minus 17 is equal to 0. This is the Cartesian equation. If they ask you to find the vector equation, that will be r vector dot 5i cap plus 2j cap minus 3k cap is equal to 17. So, hope you have understood all the three models and learned the new formulae and concepts, and you can work out similar sums of these models, right? Given 1 point, given 2 points, given 3 points, like that, so that you will be thorough with these models. Let us see few more concepts and new sums in the next part. Thanks for watching the video. Share it with your friends and classmates.